I'm going to take a closer look at why the vertical deflection on this Tektronix 7104 scope isn't happy. I've got it set up so that I can check the power supplies. So we'll switch on, and as luck would have it, they've got test points on the board there, which are nice and clearly labelled. And I've got this meter here ready to measure. Fault is still present. The trace is way off up at the top of the screen. When I switch the beamfinder off, it disappears altogether. Turn the brightness down. We don't need to be able to see it for this to save the CRT. So let's have a look at the power supply voltages. Get everything in shot. So starting at the top, we've got plus 50. It's 49.7. That's good. Plus 15. 14.8, it's all right. Plus 5, 4.8, 4.9. Minus 15, minus 14.9, that's all right. And the minus 50 volt rail is minus 49.8. Well, they're all within spec, and even if they're not perfect, they're not bad enough to stop it working altogether. So now let's have a look at what's going on with the actual voltages going through the vertical amplifier. I've got the circuit diagram here in the wonderful Tektronix manual, and you can see that there's basically three stages. There's the input from the channel switching board here, which goes into the delay line compensation network, comes out of there into this driver chip, which is that one there, and then the output of the driver chip goes into the actual driver for the CRT plates, the vertical output stage, which is another magic hypecon device, which is this one here. So we should be able to look at the signals, even in the DC conditions with no signal, and see if they make sense. So first of all, we'll try and center the trace according to this with the position control here. So if we get it sort of about in the middle, like that, we should have, because it's a differential amplifier, we should have reasonably balanced conditions across the two halves of the chain. So to begin with, down here we've got the input here and here, and it says they should be at about 8.5 volts. So if we go up here, it's a bit difficult to see. I don't want to short circuit anything. So that is one end, and that shows 8.4, and the other, it's difficult to hold the camera and do this, there, also 8.4, that's all right, that's balanced. So then the output of the compensation network, can't be very much wrong with it because there's nothing in it apart from resistors and capacitors, but the DC conditions here should be about the same. It claims 8.2 volts there, so we'll have a look. They are in here, so we'll put the probe in. We've got 8.7 on one side, interesting. And on the other side, we have 8.7. Well, it is at least balanced, even if it's not precisely the right DC level. So now the output of this driver, we should be expecting about 23.7, 23.8 volts. And I've actually checked this already, and this is where the imbalance arises. So I'll show you. Again, this is a bit difficult to see. If I get it on there, hang on, try and get a good contact. We have on one side 8.4. That's not enough. And on the other side, 23.4. So this is where the imbalance is arising. So could be something wrong with this driver chip, or it could be the output chip, or indeed something further downstream actually, because it's all terminated at a higher DC voltage. There could be something wrong. So let's have a look at the circuit diagram. You can see that this driver chip here, the output's actually open collector. So if the voltage is too low, it's probably the fault of something this side, not that chip, because the current from this stage is flowing that way into that chip and down to ground. So, yeah, because that point there is only at 15 volts. So if this point is lower than 15 volts, then it means there's current failing to arrive from here. So I suspect either there should be current coming in from the terminator through the deflection plates to here, or there's something wrong with the contacts on this chip. So I think what I'm going to do is remove this Hypecon device here, which is the main vertical output device, U862, and clean up the contacts and see if that helps. These are very fragile things with a very clever contact mechanism. And this one, I don't know if you can make it out on here, joy of joys, down in the bottom corner, hang on, shows that it's got beryllium oxide in it, which is poisonous, so I have to be extremely careful and not touch the ceramic. So I'm going to pause now, take the chip out and have a look. Okay, so I've undone the screws and taken it off. And what I find is not very pretty. The contacts do look dirty under there. And you can see, especially on the PCB, there's corrosion on those. And so I'd like to try and clean those up with something. I haven't got many solvents or anything here, and you're not supposed to use any anyway, so I'll just try brushing them gently and see if I can get some of that corrosion off. Okay, so I cleaned up the contacts on the PCB with this small stiff paintbrush. It seems to take the corrosion off quite well, and reassembled it. It's a fiddly business which I couldn't film because I haven't got enough hands, with that flat flex cable that has to be trapped in between the plastic frame and the Hypecon device. It all has to be screwed in the right round to the board. So let's see if that's fixed it. Moment of truth. Switch on. Let's have a look. Ooh. Oh look, position works. Switch the beam finder off, and we have a rather limited vertical deflection. So it's sort of now centered, much too small. What about the readout? One step forward, 2 steps back. Wonder if it's not making contact properly. Wiggle it a bit. Maybe I didn't quite assemble it right. So it's now centered, but we've lost vertical gain. Something probably isn't making contact properly. Maybe a quick tweak on the screws. There's a specified torque for these, but I don't have a torque wrench that will do the job. Or maybe I've got a fingerprint somewhere that I shouldn't have. No. So, alright, time to stop for now.